welcome back to On Your Dining Room Table. This is the final part of building your own USB controller. We've got our controller here that we've assembled over the last few weeks, and now we're ready to make it do something. Up until now, all we've done is we have taken all our switches and joystick and wired them together to our teensy. And remember, we wired them in such a way that when the button is pushed, then the connection moves to ground, right? And now using that as a basis and our Arduino Teensy Duino user development interface, which you program using the C++ programming language, which sounds scary, but you know, for the work that we're going to do here today, it's actually pretty simple, and I'll walk you through the code. We're going to be able to make this thing do some very cool things. We'll show you how to download the IDEs and how to put together the code you need, and I will also share all the code which I've used, so you can just cut and paste and play with it and learn with it. I'll put links to that in the description. So let's get started. So to get started, you have to download the Arduino development environment and then the Teensy Duino development environment installed that on top. So we're going to start at this webpage, which is arduino.cc. This is the official Arduino webpage. When you get here, you're going to go to the download section, and then once we get to the download section, we're going to install Arduino 1.6.8 or whatever the latest version happens to be. You know, if you're using Windows, you get it here, or Mac or Linux, and it's all available. So what we're going to do is we're going to download this and then install it to its whatever location, and we're going to make a note of that location because we need to install the Teensy Duino software on top of that. Once the Arduino IDE is installed, we're going to come to the Teensy Duino page. This is the address up here, pjrc.com/teensy/teensy-duino.html. And then we're going to hit this link here. It says software add-on for the Arduino, and then get whatever the latest version happens to be. And again, you pick the right one. Once you've downloaded it, the instructions are all here. You just kind of install it into the same directory as you've installed the Arduino IDE, and then we'll be ready to write some code. So now we're ready to go. This is our controller that we made in the last two episodes. Basically, it's all wired up. I kind of tied the cables neatly together. And this is our Teensy Duino right here. I've just used some blue tack to keep it in. And we've got a regular USB cable connected to it here. Now this is going to be the same cable we're going to use for both programming the Teensy Duino as well as then just using it like a normal controller, right? So by the time we finish programming it, it'll look and feel just like a regular USB controller. You just kind of plug it into your machine and away you go, right? So I'm going to start off by plugging it into my machine. The first time you do this, it kind of installs some drivers. On Windows, at least, you don't have to download any drivers or anything. I've not used it on Mac or Linux, so I'm not sure how that goes, but the Teensy Duino site has all the instructions you need anyway. But if on a Windows machine, you just plug it in, it automatically detects the drivers, and then away you go, right? So it's the normal thing. Once you've plugged it in and you've got the IDE like this running, now you're ready to write your firmware. So the smallest program is always going to have at least these two functions. So what happens is this function called setup, whatever code is in here in this space is going to get called the first time the Teensy powers up. So in other words, when you plug it into the USB and it gets power and starts up, it'll run that once. And then it will switch to running this function loop, and it'll run whatever code we define here just over and over and over again in a loop. So in other words, it'll run all the instructions, and when it gets to the bottom, it'll start again at the top and run all the instructions and so on, right? So in other words, we're going to use this top function in order to set up code, get the Teensy ready to run, do whatever pre-checks we need to do, and then in loop, we are going to actually do the real work of the firmware, right? So that's how it's going to work. So let's talk about setup first. So in the setup function, one of the important things we need to do is tell the Teensy on each of its input pins what is going to happen, right? Now you remember when we were designing our controller, we kept this cheat sheet of paper which basically told us which one of the switches, right, joystick up, down, left, right, button A, B, was connected to which pin in the Teensy. So this is the point at which we are going to enter this same information into our setup function, right? So we are basically going to tell the Teensy, hey, when you see a signal on pin 27, that means that the joystick went up, right? And so we need to first tell the Teensy, okay, these pins here, 27, 0, 1, 2, 3, blah, 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 are going to be input pins. And we're going to tell them which are digital and which are analog. And then we are going to, in the loop function, say, if you see a signal on 1, then go ahead and, you know, implement the joystick up. So let's enter that in the setup first. And it's very simple. there is a function which is called pin mode. Pin mode. And this tells the pin whether it's going to be an input pin or an output pin. Now, because we are basically using the switch to make a change on the Teensy Arduino to send a signal, these are going to be inputs, right? Because we are inputting a signal into the Teensy from the joystick or the buttons. And so let's implement, for example, button number 3, which in our design is button A. And we're going to say this is an input pin. But we're going to make things slightly more complicated. We're actually going to use the keyword input pull-up. Because we want the pull-up resistor that's inside the Teensy Arduino to be activated. It's kind of a technical detail. We don't have to go into it. If somebody's interested, they can leave a comment asking to explain what input pull-up means. But you can pretty much always use input pull-up if you're doing a digital switch, and it works really well, right? So now we've got our, let's imagine we want to do just a single button push. Now our setup is done, right? That's all we need to do. Now when I send this to the Teensy, and I can use this button here to compile the code and send it up to the Teensy, and that's it. Now we see down here that it says it's done uploading. It tells us how much memory our sketch used. So in other words, this program is using 49 bytes on the Teensy Arduino. And now what happens is when the Teensy starts, it will configure itself so that pin number 3 is in input pull-up mode. So now in our loop function, we're actually going to do the work, right? And what we're going to do is we're going to check the button to see if it was pressed. And if it was pressed, then we're going to take some action. And let's say we're going to do a key press. We'll press the letter J when the button is pushed. Why not, right? Just to show you how it works. So what we're going to do is we're going to call a particular function which is called digital read. And what digital read will do is the Teensy is going to look at a pin and decide whether it is in a high state, meaning it's connected to plus 5 volts, or in a low state, meaning it's connected to ground, right? So we're going to pass the pin we want to read, so we're going to say digital read 3, because remember, 3 is the same pin that we've set up here as our input pin, right? So we set up pin 3, and here we're going to read it. And so now, digital read 3 is going to return either high or low, depending, right, on what the state of the thing is. If we've pushed the button, it's going to return high because of our input pull-up statement. And remember how we wired the cables on the controller, right? We had it so that when the switch was closed, it was connected to ground, which means that that is going to set it to low. So in other words, if we see this condition where digital 3 is returning low, that means that the button is pushed. If we don't see that, then it means that the button is not pushed, right? So what I'm going to say is, if digital 3 equals low, then I want to take some action. And the action I want to do is I want to press the key J, right? So I'm going to say keyboard.press key J, for example, right? Okay, so in other words, this is what our program does. When you plug in the Teensy, it sets up pin 3 to be input pull-up, and then it starts running loop over and over and over again, right? Thousands of times a second. This is like a 3 megahertz processor or something like that. If it's going to read pin 3, if pin 3 returns low, in other words, if it's being actually pressed, then we are going to press key J on the keyboard. So let's compile that and see what happens. Compile. Let's make sure we didn't have any problems. It's done uploading. Okay, we're ready to test. Let's see what happens. Okay, here's our controller. I'm going to plug it in. There we go. Okay, so the minute I plugged it in, the setup function was run, and now it's waiting. It's running the loop function over and over again, right? So let's have a look at this instance of Notepad I have here. When we press this button, we expect the key J to be pressed, right? So let's press it. Oh, there it goes. Look at that. Now I'm going to let go. Hey, what's going on? It's still going. Why is it still going? We let go. The reason it's still going is because we haven't released the key, right? When you do a key press on the Teensy Arduino, essentially you have to simulate both pressing the key and releasing it. Otherwise, as far as the Teensy Arduino is concerned, the key is still pressed, right? So let's change our code to fix that bug. So let me unplug this so it stops doing that. And let's go and look at our code again. So we need to be releasing this key. So what we're going to say is, if digital 3 equals low, in other words, if the button is pushed, then yes, I want to press the key. But if it's not pushed, so if it's digital 3 digital read 3 is low, we're going to do it, else we're going to say release the key, right? We don't want it pressed anymore. Oh, typo. There we go, right? So if the pin is low, meaning the switch is closed, we're going to press the key, else we're going to release the key. All right, let's compile that and test it. Oh, okay. I need to plug it in order for it to compile, of course. All right, let's try that again. And now we're done. All right, let's give it a test. Okay, here we go. I'm going to press it, and we should see J's appearing, and when I let go, the J should stop, right? And let go, it stops. Okay, there we go. We now have this button behaving like a regular key press. Now all we need to do is program the rest of the buttons, and away we go. Let me show you how to add a second button to this program, and then, you know, if we're adding 8 or 10 or 15 buttons, it doesn't matter, it's the same logic. So for every single button that we want to read, we're going to add one of these pin mode lines in setup, and then we're going to add a little block of text like this in the loop, right? So let's take our B button, which is number 4. We're going to say pin mode 4, comma, input pull up. And then we are going to do the same thing, so I'm just going to copy and paste this. And let's say that for button B, we want to push the, I don't know, the L key. Why not? So in other words, if digital read 4 now, right, because we are working with pin 4, right, so the same one we defined here, we're working with now. So pin 4 is low, meaning it's pressed. We are going to press the L key. Otherwise, we're going to release the L key. Now, be careful when you're doing this to actually make sure that the same key is here, because if you press one key and release the wrong one, you'll still keep the stuff will keep appearing, right, because you're releasing the wrong key. The other thing you need to do when you're writing code like this, you know, just for good kind of form, is you should comment what this is, right? So I'm going to put a little comment here. I'm going to say this is the B button. And I'll put the same thing up here for A. Now, when you put 2 slashes like this in C++, it means that the compiler ignores it. That's something for you to read, for humans to read, not for the computer. So it's going to ignore this line. And it's important that we put this here, because when we have put all 12 buttons in this code, it's just going to be, you know, hundreds of lines of the same stuff. It's going to be very difficult for us to figure out which is which. So putting a little comment like this helps you find your stuff. All right, so let's compile this, test it, and see if it works. It's plugged in this time. That's it, we're done uploading. Our program is huge, it's using 91 bytes of memory, 91 bytes. Okay, let's give it a try. So we had button A before, which did J, and of course that continues to work because we didn't touch that code. Now here's button B, let's see what it does. It does L, and when I let go, it stops. There we go. So now we've got 2 different buttons working. Now, what about joystick, right? Because we did say that the Teensy Arduino could simulate a keyboard and a joystick. So let's change our program, so instead of doing keyboard presses, it does joystick button presses. A joystick button is still just a digital input, so it's going to look very similar to the keyboard keys, right? We're still going to use input pull up, just like we did before, and let's keep it on the A button just for demonstration purposes, right? So just like before, we are going to read pin 3 and see if it's pushed or not, right? So that part remains exactly the same. The digital read 3 equals low. Now, of course, the action will be different, because now we want to do a joystick button push rather than a keyboard push, right? And the command for that is joystick.button, and here it gets a little different. The first thing we're going to pass here is which joystick button. Now, the Teensy Arduino simulates, I think, joysticks with 16 buttons, so you could pass 1 for button 1 or 8 or 7 or whatever you want, right? We'll use button 1, just why not? And then the second thing you pass is 1 if the button is pushed, a 0 if it's released, right? So we're going to push 1. And what this means is, if we read pin 3 and we find it's low, meaning the switch is closed, then we are going to set button 1 to pushed. And just like the keyboard, you got to release, right? Because if you don't release, it look like the button is pushed the whole time. So what we're going to do for release is we're going to say joystick.button, still button 1, but this time 0 because we want to release it, right? So this is what it looks like. So let's compile that, test it, and see if it works. Done uploading, everything's looking good. Let's give it a try. Okay, so to test the joystick, I've opened up the game controllers dialog in Windows, and you'll see that there's one here which is called Serial Keyboard, Mouse, and Joystick. That's your Teensy Arduino, right? So let's crack this open, and now you get this really nice joystick testing interface, which is something about Windows I really like. So let's look at button number 1 here. Oh, actually it supports 32 buttons. Wow, that's huge. Okay. So now when I push my A button, we expect button 1 to light up. So let's see if it happens. Oh, there it goes. It lights up, and when I let go, it releases. And there you go, right? That's a joystick button. So now what about the joystick itself, right? Like the joystick axes. Now we have a digital joystick here. So we want to do a thing where if you push the joystick to the right, say, we should get the maximum deflection on the right, which would be the same as slamming the joystick all the way. Because remember, in Windows, joystick axes are always analog, right? So what we're going to do instead is we're going to say if the joystick is pushed, we're going to move it all the way to the right, all the way to the left, all the way up, all the way down. So let's see what that looks like. Okay, so let's get ready for moving the analog stick. So this is the function that we use to move the X or Y axis, right? Joystick.X or joystick.Y, and then you pass it a number. And this number is going to be between 0 and 1023. 0 means the joystick is moved all the way to the left, and 1023 means it's moved all the way to the right, and then anywhere in between, right? And obviously halfway in between, which is 512, is centered, right? So that's what we're going to do. So the way we do this is a little different from the calling the buttons, for reasons which we can go into in the comments if someone is interested. But we'll start off by declaring two values here, X value and Y value, and we're going to set them both to be 512. In other words, by default, we want our joystick centered, right? So whenever we enter the loop, we expect the joystick to be in the center. Then, if we have gotten input from the user that the joystick is actually moved in some particular way, we'll overwrite this value and then send it to the joystick, right? So in other words, we start off saying X value is 512 centered. If someone is using pin 2, which is pushing right on the joystick, then we're going to make X value 1023. But if this doesn't happen, then we won't overwrite this default value of 512, and it'll continue to be 512 when we actually set the joystick to that. But if the user is pushing to the right, then we will overwrite the value and send it all the way through, right? So let's see how that works in practice. Let's compile it and send it up to the Teensy. Okay, here we go. There is our Teensy again. Now we are looking at this area here. We want to see what this cross does, right? So right now I'm not touching the joystick and it's centered, which is correct. Now when I push to the right, we want to see the cross move over to the right. And there it is. And then when I let go, it comes back to center, right? Very simple. And I can modify the code very simply to do left as well. So what I'm going to do is I'm going to just change this value here. Now my left pin, according to my cheat sheet, is pin number 1. So I'm going to change my value here to be 1. I've already set up all my pins here as input pull-ups. And I'm going to say if 1 is pressed, which means the joystick is all the way to the left, then we're going to set value 0. All right, so let's send that over to the Teensy. Okay, let's open that again. And now when you push right, it goes right, and when you push left, it goes left. So that's the x-axis. And we can add the y-axis in a very similar way, right? Instead of joystick.x, we're going to do joystick.y. And I'm going to send it y value this time. And I'm going to do the same thing here. Which was our up button? Up was pin 27. So I'm going to say if digital read 27 is low, then we are going to move up, which is y value of 0. And if, which is my down? Down is 0. So if digital read 0 is low, then I'm going to set maximum on the joystick, which is 1023. All right, let's do it. All right, we've uploaded. Let's close that guy, open it up again. I always close and open that just to be sure that I'm getting the new values. My left and right still works, and now up and down works. And there we go. We got joystick working. Easy as that, right? Once you've got the basic structure, adding additional functions is just a case of doing more of the same. Super, super easy. Okay, the last thing I want to show you how to do is, remember when we built the controller, we did put one analog control in there just so I could show you how that works. So let's see how to set that up. And it's kind of similar to everything we've been doing so far, because in the end the programming system is fairly straightforward, right? So we need to set up our pin again. Of course, you always need to do that. So pin mode, and it turns out that we wired this to pin 38 on the Teensy, our analog. But this time I'm not going to ask for input pull up, I'm just going to ask for input, right? So that is important. When you do an analog input, don't use input pull up, just use input, right? So now what we need to do in our loop is we need to read that value, right? And normally we would use digital read, but remember this time it's not digital input we're reading analog input, right? So we need to use a different function. And as you would expect, instead of being called, you know, digital read 38, which is what we would have used for a switch, we're going to use analog read. Spell it right, analog read on pin 38. And that is going to return me a value. Now, when you did digital read, you would either get back high or low. This time, we're actually going to get back a number between 0 and 1023. 0 means that you've got the smallest setting on your analog value, 1023 is the largest, right? So I can actually plug this straight into the joystick axis function. So I can say joystick.x, for example. Actually, I'm going to use the z-axis, just why not? And then I'm going to pass this in. So what's going to happen here is analog read will read the analog input, and it's going to return a number between 0 and 1023, and then that is going to go and it will become the value of joystick.z, right? So let's try that and see how it works. Compile, and there we go, we've uploaded. Let's see how it runs. Okay, let's test it out. So on our controller, this little guy here is connected to pin 38. That's our analog input. This is the z-axis, this line up here. So we're going to look for this line to change. So let's do it. I'm going to move this, and there it goes. It gets bigger and it gets smaller, and it's completely analog, right? And I could very easily hook that up to the X or Y axis. I just need to change my code. Instead of being joystick.z, I would make it joystick.x or Y or any of these other axes, right? Because the Teensy actually gives you, how many is it? 2, 3, 4, 5, 6 axes to play with. And so this way I can do, you know, a real joystick with, you know, proportional control and all the rest of it. Super, super easy to do. Okay, so I just want to close off showing you why it's cool to be able to build your own controllers. So I've made a change to the code, and it's all in firmware, right? I haven't changed anything about how the controller itself is wired. And I've got the joystick properties over here and the notepad here, right? So as it is now, you can see the joystick indicator is moving and the buttons are lighting up. So this is basically a keyboard, a joystick controller. But now watch what happens. I'm going to flip this switch here. And now, hey, now it's behaving like a keyboard all of a sudden. And I can flip the switch back the other way, and it's back to being a joystick, right? So I've basically added a mode switch here, which allows it to switch between operating either as a keyboard or a joystick. And this is cool, right? Because, for example, you could be running an emulator which needs certain keyboard input, and then if you want to switch to playing a different kind of game that wants analog, you can do that. So all that stuff is completely in your control through the firmware. Okay, let's have a quick look at how I did that. So what I did was, in our sheet we had the special mode button, which was connected to pin 7, right? So I've added that just as an extra pin in my setup function, as you would expect, right? And it's an input pull-up. So now what we're going to do is, if that switch, because remember this is a kind of flip switch, it doesn't return to center, so we're going to say if the switch is high, it's going to be in keyboard mode, and if it's low, it's going to be in joystick mode, right? So that's all I've done in my setup. I've just said, hey, this is yet another switch that I need to use. Now if we go to my loop function, what I say is if digital read 7, so in other words, if the mode switch is low, then call this new function I've defined called loop keyboard. And if it's not low, then loop joystick, right? And here I just put my logic for handling keyboard and handling joystick. So let's go look at the keyboard code. Here it is, loop keyboard, and it's the same thing we've talked about, right? If digital reads some key, then we're going to do that, else we're going to release it. If it's a different switch, we're going to do the press and the release, and it's just all the different buttons configured. And then in the joystick code, it's the same thing, right? here's Joystick Loop, and here we do exactly what we've discussed, right? We set it to center, and then if the switch is pressed, we're going to override it, and then we're going to set the joystick value, right? So you get enormous amounts of functionality in the firmware by being able to do things like this, right? And so that is one of the reasons why it's very cool to be able to do this stuff on your own. Okay, someone actually asked me this afternoon, like, hey, how would I go about doing macros on a keyboard, right? You know, when you press one button and you get a bunch of stuff that happens. And it's actually something that's really, really easy to do. What you need to do is you need to make use of this function called delay. And what delay does is it basically, the program will wait for some number of milliseconds, right? So you can set this to be any number you want, you know, 750 milliseconds, you know, 1000 is a whole second, etc. So what we can do is something like this. We can, for example, press a key, wait a little bit, then release the key, and so on, right? So let's do 500, why not? That seems to work pretty well. So what we're going to do here is we're going to press the H key, wait half a second, release the H key, wait half a second, right? So let's send that over to the teensy. Okay, so now let me just put the cursor down here and show you what happens. Push the button, and it pushes and releases the key. Not too impressive. But now watch what happens if we start to add other things here. Let me add a little bit of code. And presto, let's see what happens there. Send that to the teensy. Oopsie daisy, I've got a bug somewhere, forgot my bracket. There we go. Alright, let's press the button. And look at that. Okay, so it's got a little bit of problems because you need to take care of the timings correctly, right? So the code needs to be worked on. But basically, by using these delays, you can send entire sequences of characters, right? So you could have a single button on your controller that just issues the Konami code, right? Or you could have, you know, a single button that does, you know, the killer combo in Street Fighter 2 or whatever it is. So you have absolute control over everything that happens in your controller. You can decide when buttons are pushed, released, two buttons pushed together, one release, any combination you want, right? That is what makes it fantastically cool to be able to write your own firmware for this stuff. Alright, so that is then the final episode in building your own USB controller. I mean, you know, it's not very much to look at, but, you know, you could put a little effort to put it in a nice box. And by understanding how to write the firmware, you can have a huge amount of control over what happens, right? What buttons are pushed, whether it's a joystick, it's a keyboard. You can also make it look like a mouse. The mouse code looks pretty much the same as the joystick control, so you can make this be mouse controls. You have absolute control over what it can do. You have absolute control over how it looks. So you can be really creative and make some really cool things to do exactly what you need to do. So that's it for this episode of On Your Dining Room Table. I hope you enjoyed that, and let me know what you think in the comments. What's the next project you'd like us to build? Is it storage? Is it something else interesting? Let us know. Otherwise, until then, take care.